In P2, we're trying to find the change of coordinates matrix from the basis B to the standard basis. And then we're going to try to find the t squared as a linear combination of these polynomials. Our goal is to be able to express the same vector v either with these basis vectors, maybe C1, C2, C3, using those vectors from C, or we should be able to express that same vector using these vectors here, which would require different coefficients, say b1, b2, and b3. And then we would have to use those particular basis vectors. Well, there's all sorts of vectors that we could form, but let's try to form an easy one, like for example, this one right here. In order to form this vector with the b basis vectors, wouldn't it be possible to say, okay, let's go 1 minus 5t squared, that's the first basis vector there. We need some coefficient there, and then we need the 2 plus t minus 9t squared over here, and then we also need a 1 plus 4t. But our goal was to create a 1 minus 5t squared. Now, it would be pretty easy to do that because we can just go 1, 0, 0, and then we would get 1 minus 5t squared. But let's say we wanted to form the same vector using these basis vectors. Well, then we would have to go something like 1, and then have a coefficient there, plus t over here, and then plus some other one for t squared. And then that would also give us 1 minus 5t squared. Well, clearly, all we need to do is just put in a 1 here, a 0, and then a negative 5. Before we move on, let's just rewrite this a little bit better. So we'll say that 1t and then t squared times the 1, 0, negative 5 is going to be equal to the 1 minus 5t squared. So we've sort of written that coefficient as a column here. If we return to these vectors, then we'll notice that C1, C2, C3, using the basis vectors from C, that would just simply be equal to 1, 0, negative 5 here. 1, 0, negative 5. And then we could notice over here, this would have been 1, 0, 0 for these B's. So we could say that B1, B2, B3, using basis B, is 1, 0, 0. Okay, we're going to label this as C and label this as B. So let's just kind of realize what happened on the side over here. Basically, we have a transformation that was able to take this 1, 0, 0 vector and then move it into, transform it into 1, 0, negative 5. Well, that matrix that was involved in that transformation is actually going to be equal to this matrix that we're looking for right here. P in this case, and then we're transforming B's into C's, as we can transform this B thing here into this C thing here. If that's true, that means that there's going to be some x1, x2, x3, y1, y2, y3, z1, z2, z3, that when we plug in 1, 0, 0, that gives us 1, 0, negative 5. Notice that this is just telling us that we need one of these columns, and then 0 of those and 0 of those, and then we get this. So that means that this answer right here is just going to be equal to x1, x2, and x3. So we already have one of those columns for this matrix. So let's just start filling in our matrix over here real quick. We're going to put in the first column, 1, 0, negative 5. And then we're expecting 2 more columns. Let's get those by finishing this up. We're going to go 1t, t squared, and we're going to figure out what we would need in order to get the next vector, which is this one. We're going to choose to create this one. So 2 plus t minus 9t squared. And in order to do that, we just simply need a 2, and then we need a 1, and then we need a negative 9. So now we can sort of fill this in for the next column over here, 2, 1, and negative 9. And then we can try that for the last vector here. We're going to need a t and then a t squared. And then this is going to be something which is going to create 1 plus 4t. Well, this would just be 1, a 4, and a 0. So now we found the third column. We'll plug that in here, 1, 4, 0, and boom, we've got the matrix we're looking for. At this point, our goal is to create t squared using these basis vectors. But let's recall we could also create t squared by using these basis vectors. So let's set up the idea that we could take 1 times some coefficient plus a t times some coefficient plus the t squared and some coefficient, and then that will just give us t squared. Now, obviously, this is going to be 0, 0, and a 1. We're also looking for this to sort of work. We have to have a 1 minus 5t squared, and then we have to add in some coefficient here with a 2 plus a t minus 9t squared, and then some other coefficient here with a 1 plus a 4t, and that's also supposed to equal t squared, but we don't know these coefficients yet. But that's okay. Let's recall there should be some transformation that takes our coefficients that we use with the b basis vectors and then transforms it to give us some sort of coefficients over here that we're using for the c basis vectors. But we actually already have that one, so it's going to be a 0, a 0, and a 1. And over here, let's just label these a, b, and c or something. A, b, and c. And that's great, because now we can actually use the same matrix from before. So let's load up the matrix, sort of like 1, 0, negative 5, 2, 1, negative 9, 1, 4, 0. And we know that we need to multiply that by some a, b, c, and that's going to turn into a 0, 0, 1. And at this point, you just go through the general row operations to be able to solve this, and you'll be able to find that a equals 7, b equals negative 4, and c equals 1. And that just simply means that if we put a 7 here, and a negative 4 here, and then a 1 right here, then that would be the way to create the t squared by using the b basis vectors. Oh my god.